Alright, now we're going to talk about molecular formulas and how to find those. Alright, so molecular formula, again, it's the actual composition of the molecule, and it's either going to be the same as the empirical formula or some simple whole number multiple of the empirical formula. So this is what we're going to do. And again, just a reminder, this would be a molecular formula for benzene, C6H6, but the empirical formula, simplest whole number ratio, is CH, one carbon atom for every one hydrogen atom, or 1 mole of carbon atoms to every 1 mole of hydrogen atoms. But the chemists know the formula by C6H6, which describes the molecule and is called the molecular formula. Okay, so again, a long number of steps for how to go about doing this, but let's take it through a specific example. Alright, so here we have a problem. We have a sample, we've analyzed it, and we know it's got 40% carbon, 53.4% oxygen, 6.6% hydrogen. We also know the molar mass of the compound, which is 120 grams per mole. Okay, so what we're going to do is start out by finding the empirical formula, as we described in the previous podcast. So we've got 40 grams of carbon. We're going to divide by the molar mass. We get 3.3 moles of carbon. Do the same thing with oxygen, 3.34 moles of oxygen and 6.54 moles of hydrogen. We're going to take each of those and divide by the smallest number, which is 3.33. So we end up with a ratio of 1 for carbon, 1 for oxygen, and 1.96 for hydrogen. Okay, so that gives us an empirical formula. This is pretty much a whole number, 1, 1, and 2 of COH2. So that's our empirical formula. Now what we want to do is find the molecular formula. We're going to compare the molar mass for the empirical formula to the molecular formula. Okay, so if we find the molar mass for COH2 from the previous slide, remember COH2, it's got 12 grams of carbon, 16 grams of hydrogen, 16 grams of oxygen, and 2 grams of hydrogen, and that's going to give us a molar mass of 30.03 grams per mole, which does not equal what was given to us in the problem, which is 120 grams per mole. So step 2 says if they're different, we divide the given molar mass by the empirical molar mass. So I'm going to divide this number by what I got from my empirical formula, and I get a ratio of 4. Whoops. So last step is to take and multiply the subscripts from the empirical formula by the answer in step 5. So I'm going to multiply the 1, 1, 2 by 4, and I end up with C4O4H8.